Classless inter-domain routing is a method for allocating IP addresses and routing Internet Protocol packets. The Internet Engineering Task Force introduced cáIDR in 1993 to replace the previous addressing architecture of class-file network design in the Internet. Its goal was to slow the growth of routing tables on routers across the Internet, and to help slow the rapid exhaustion of IPv4 addresses. IP addresses are described as consisting of two groups of bits in the address. The most significant bits are the network address, which identifies a whole network or subnet, and the least significant set forms the host identifier, which specifies a particular interface of a host on that network. This division is used as the basis of traffic routing between IP networks and for address allocation policies. Class-file network design for IPv4 sized the network address as one or more 8-bit groups, resulting in the blocks of class A, B, or C addresses. Classless inter-domain routing allocates address space to Internet service providers and end users on any address bit boundary, instead of on 8-bit segments. In IPv6, however, the interface identifier has a fixed size of 64 bits by convention, and smaller subnets are never allocated to end users. Cidr notation is a syntax for specifying IP addresses and their associated routing prefix. It appends a / character to the address in the decimal number of leading bits of the routing prefix, for example, 192.168.2.0/24 for IPv4, and 2001, db8/32 for IPv6. Background: during the first decade of the Internet after the invention of the domain name system, it became apparent that the devised system based on the class-file network scheme of allocating the IP address space and the routing of IP packets was not scalable. To alleviate the shortcomings, the Internet Engineering Task Force published in 1993 a new set of standards, RFC 1518 and RFC 1519, to define a new concept of allocation of IP address blocks and new methods of routing IPv4 packets. A new version of the specification was published as RFC 4632 in 2006. An IP address is interpreted as composed of two parts, a network identifying prefix followed by a host identifier within that network. In the previous class-file network architecture of Internet Protocol version 4, IP address allocations were based on the bit boundaries of the 4 octets of an IP address. An address was considered to be the combination of an 8, 16, or 24-bit network prefix along with a 24, 16, or 8-bit individual or node address. Thus, the smallest allocation and routing block contained only 256 addresses, too small for most enterprises, and the next larger block contained 65,536 addresses, too large to be used efficiently by even large organizations. This led to inefficiencies in address use as well as routing because the large number of allocated small networks with individual route announcements, being geographically dispersed with little opportunity for route aggregation, created heavy demand on routing equipment. As the initial TCP/IP network grew to become the Internet during the 1980s, the need for more flexible addressing schemes became increasingly apparent. This led to the successive development of subnetting and cidr. The network class distinctions were removed, and the new system was described as being classless, with respect to the old system, which became known as Classful. Classless inter-domain routing is based on variable-length subnet masking, which allows a network to be divided into variously sized subnets, providing the opportunity to size a network more appropriately for local needs. Variable-length subnet masks are mentioned in RFC 950. Accordingly, techniques for grouping addresses for common operations were based on the concept of cluster addressing, first proposed by Karl Herbert Rokitansky. cidr encompasses several concepts. It is based on the VLSM technique with effective qualities of specifying arbitrary length prefixes. cidr introduced a new method of representation for IP addresses, now commonly known as Cidr notation, in which an address or routing prefix is written with a suffix indicating the number of bits of the prefix, such as 192.168.2.0/24. Cidr introduced an administrative process of allocating address blocks to organizations based on their actual and short-term projected needs. The aggregation of multiple contiguous prefixes resulted in subnets in the larger Internet, which whenever possible are advertised as aggregates, thus reducing the number of entries in the global routing table. Cidr Notation. Cidr notation is a compact representation of an IP address and its associated routing prefix. The notation is constructed from the IP address and the prefix size, the latter being equivalent to the number of leading 1 bits in the routing prefix mask. The IP address is expressed according to the standards of IPv4 or IPv6. It is followed by a separator character, the / character, and the prefix size expressed as a decimal number. The common routing prefix mask 255.255.255.0 has 24 leading 1 bits, hence in Cidr notation an address will use /24 as a routing prefix size, for example 192.168.0.1/24. The address may denote a single, distinct interface address or the beginning address of an entire network. The maximum size of the network is given by the number of addresses that are possible with the remaining, least significant bits below the prefix. This is often called the host identifier. For example, 192.168.100.0/24 represents the given IPv4 address and its associated routing prefix 192.168.100.0, or equivalently, its subnet mask 255.255.255.0. The IPv4 block 192.168.100.0/22 represents the 1024 IPv4 addresses from 192.168.100.0 to 192.168.103.255. The IPv6 block 2001, DB8/48 represents the IPv6 addresses from 2001, DB80000000 to 2001, DB80FFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFF loopback address. Its prefix size is 128, that is the size of the address itself, indicating that this facility consists of only this one address. Before Cidr notation, IPv4 networks were represented using dot decimal notation for both the address and the subnet mask. Thus, 192.168.100.0/24 would be written as 192.168.100.255.255.255.0. The number of addresses of a subnet defined by the mask or prefix can be calculated as 2 address size, prefix size, in which the address size is 128 for IPv6 and 32 for IPv4. For example, in IPv4, a prefix size of /29 gives 232-29 equals 23 equals 8 addresses. Subnet masks. A subnet mask is a bit mask that encodes the prefix length in core dotted notation, 32 bits, starting with a number of 1 bits equal to the prefix length, ending with 0 bits, and encoded in 4-part dotted decimal format. A subnet mask encodes the same information as a prefix length, but predates the advent of Cidr. However, in Cidr notation, the prefix bits are always contiguous, whereas subnet masks may specify non-contiguous bits. However, this has no practical advantage for increasing efficiency. Cidr blocks. Cidr is principally a bitewise, prefix-based standard for the representation of IP addresses and their routing properties. It facilitates routing by allowing blocks of addresses to be grouped into single routing table entries. These groups, commonly called Cidr blocks, share an initial sequence of bits in the binary representation of their IP addresses. IPv4 Cidr blocks are identified using a syntax similar to that of IPv4 addresses, a dotted decimal address, followed by a /, then a number from 0 to 32, for example, ABCDN. The dotted decimal portion is the IPv4 address. The number following the slash is the prefix length, the number of shared initial bits, counting from the most significant bit of the address. When emphasizing only the size of a network, the address portion of the notation is usually omitted. Thus, a /20 block is a cidr block with an unspecified 20-bit prefix. An IP address is part of a cidr block, and is said to match the cidr prefix if the initial n bits of the address and the cidr prefix are the same. The length of an IPv4 address is 32 bits, an n-bit cidr prefix leaves 32 n bits unmatched, meaning that 232 n IPv4 addresses match a given n-bit cidr prefix. Shorter cidr prefixes match more addresses, while longer prefixes match fewer. An address can match multiple cidr prefixes of different lengths. cidr is also used for IPv6 addresses and the syntax semantic is identical. The prefix length can range from 0 to 128, due to the larger number of bits in the address. However, by convention a subnet on broadcast MAC layer networks always has 64-bit host identifiers. Larger prefixes are rarely used even on point-to-point links. Assignment of Cidr blocks. The Internet Assign Numbers Authority issues to regional Internet registries large, short prefix Cidr blocks. For example, 62.0.0.0/8, with over 16 million addresses, is administered by RIPE NCC, the European RIR. The RIRs, each responsible for a single, large, geographic area, such as Europe or North America, subdivide these blocks and allocate subnets to local Internet registries. Similar subdividing may be repeated several times at lower levels of delegation. End-user networks receive subnets sized according to the size of their network and projected short-term need. Networks served by a single ISP are encouraged by IETF recommendations to obtain IP address space directly from their ISP. Networks served by multiple ISPs, on the other hand, may obtain provider-independent address space directly from the appropriate RIR. For example, in the late 1990s, the IP address 208.130.29.33 was used by www.freeasoft.org. An analysis of this address identified 3 Cidr prefixes. 208.128.0.0/11, a large Cidr block containing over 2 million addresses, had been assigned by ARIN to MCI. Automation Research Systems, a Virginia VAR, leased an Internet connection from MCI and was assigned the 208.130.28.0/22 block, capable of addressing just over 1,000 devices. ARS used a /24 block for its publicly accessible servers, of which 208.130.29.33 was one. All of these Cidr prefixes would be used, at different locations in the network. Outside of MCI's network, the 208.128.0.0/11 prefix would be used to direct to MCI traffic bound not only for 208.130.29.33, but also for any of the roughly 2 million IP addresses with the same initial 11 bits. Within MCI's network, 208.130.28.0/22 would become visible, directing traffic to the lease line serving ARS. Only within the ARS corporate network would the 208.130.29.0/24 prefix have been used. IPv4 Cidr blocks, for routed subnets larger than /31 or /32, the number of available host addresses is usually reduced by 2, namely the largest address, which is reserved as the broadcast address, and the smallest address, which identifies the network itself. IPv6 Cidr blocks, the large address size used in IPv6 permitted implementation of worldwide route summarization and guaranteed sufficient address pools at each site. The standard subnet size for IPv6 networks is a /64 block, which is required for the operation of stateless address auto-configuration. At first, the IETF recommended in RFC 3177 as a best practice that all end sites receive a /48 address allocation. However, criticism and re-evaluation of actual needs and practices has led to more flexible allocation recommendations in RFC 6177, suggesting a significantly smaller allocation for some sites, such as a /56 block for home networks. Prefix aggregation. ʻsʌɪ.dr provides the possibility of fine-grained routing prefix aggregation. For example, 16 contiguous /24 networks can be aggregated and advertised to a larger network as a single /20 route, if the first 20 bits of their network addresses match. 2 aligned contiguous /20 blocks may be aggregated to a /19, and so forth. This results in reduction of the number of routes that have to be advertised. See also, Internet Protocol Suite, IPv4 subnetting reference, IPv6 subnetting reference, references. External links, RFC 2317, Classless Inter-Domain Routing delegation, RFC 3021, using 31-bit prefixes on IPv4 point-to-point links, cidr report, cidr FAQ.